Well, believe it or not, guys, we're halfway done with Unit 7. It's a short one. And today we're going to be working on factors again. Remember what factors are. Factors are when we multiply a number by another number to get a target number. So an example of the factors of 20 is 1 and 20. Another way to get 20 is 2 times 10. So these are both factors, 2 and 10. And 4 times 5 are also factors of 20. Now, how do we know when we get all the factors? Do we just keep going on forever? No, there's a strategy. That's what we're going to use today. It's called repeated reasoning. So let's dive in. Ms. Maribel wants to arrange 20 desks in her classroom into rows with the same number of desks in each row. She wants at least 2, but no more than 8 rows. So what are the factor pairs for 20? Explain how you know you found them all. So we're basically asking, how do we get the number 20? What numbers do we multiply to get 20? Well, our factor pairs are what? Well, we have this strategy from our visual learning called repeated reasoning. And so what I do is I start with the number 1, and I think 1 times anything, does that equal 20? And our answer is yes, 1 times 20. So these are both factors, 1 and 20. Then I go to the next number. I start with 1, so I go to 2. 2 times anything, does that equal 20? Yeah, 2 times, and actually I'm going to get rid of that comma. And I'll zoom in for us. 2 times 10 equals 20. What about 3? Well, if I look at my multiplication chart and know my facts, I know it goes 3 times 6 is 18, 3 times 7 is 21. So there's nothing that will equal 20. So now let's go to 4. 4 times what? Well, on my multiplication chart, I see 4 times 5 equals 20. And here's going to be my key part. I've done 1, 2, 3, 4. So now 5, and 5 times 4 equals 20. When I start seeing my factor pairs repeating, so I have 4 times 5 and 5 times 4, those same numbers, when they start repeating, that means I've found all of the factor pairs. So 1 and 20 are factor pairs, 2 and 10, 4 and 5. And then it starts repeating. So I have all of my factor pairs. So what do I need to write? Well, I'm going to answer my question. It says, what are the factor pairs for 1 and 20? So I'm going to list them. 1 and 20, 2 and 10. Notice it says factor pairs, not factors, so that's why I'm putting them in groups instead of smallest to largest. And then how did we find them? So I started with 1 and 20. Then I tried 2 and found 10. Then what I do with 3? 3 is not a factor. But 4 was. And then what do I know? When I tried 5, what did I notice? I noticed that its factor pair was the same. I noticed that 5 and 4 is the same pair as, what was it? I need to flip them. 4 and 5, there we go. So there are no more pairs. Sorry for that sloppy handwriting, guys. So now I can move on to number 2. So it says, find the ways Ms. Maribel can arrange the desks. So she can make 2 rows of 10. What else can she do? She could do 4 rows of 5. And notice, even though these are the same pairs, it's actually set up differently in real life. We can do 5 rows of 4. So what does that mean? Well, I could have 1, 2, 3, 4 rows of 5. So here's my 4 rows, and there's 5 in each row. Or I could have done it this way. 5 rows of 4. So notice it still has 20, but the number of rows is different, and the number of desks in each row would be different. Now, what about this one? 10 rows of 2. Can we do that? No, because at the very top right here, it says we don't want more than 8 rows. So that is all the answers that I have. Now, let's head on to our next one at the bottom. It says Kevin invited 15 friends to his birthday party. They played a game where everyone had to separate into groups. So, separate into groups, that sounds like division to me, maybe. Each group had the same number of children. The game could not be played with all 16 children in one group. Where'd this 16 come from? Because it said 15 right here. Oh, that's right, Kevin's included because it's his party. He's not going to be left out. So that's where my 16 comes from. And each group had to have more than one kid. So we can't have all 16 together, and we have to have more than one kid. So our first thing says list the factor pairs of 16, and then the different ways that we can organize it. Well, we start with 1 times 16, because that equals 16. Then we go to our next number after 1 is 2. 2 times 8, and I'll zoom in for us, which equals 16. What about 3? Well, 3 times nothing equals 16, so 3 is not a factor. Then we go to 4. 4 times 4 equals 16. And notice, this is a repeating factor pair. If it's the same number, 4 and 4, that's repeating. We've seen that 4 before, so now we're done. So there are all of our factor pairs. Now, here's our tricky part. Since it wants our factor pairs, we have to remember that we can also flip these too. So when we're making those groups, we could also do 8 times 2 though, but we don't have to do any math. We just need to remember that we can flip them, and 16 times 1. So now let's go to number 4. Why does 16 have an odd number of factors? Well, what are my factors? It's 1, 2, 4, 8, and 16. They're right. There's 5 factors. When we had 20, it was 6 as an even number. So why is it an odd number? Oh, that's right, because there's this sneaky guy right here. That 4 repeats. So one factor pair has what? One factor pair has the same number. And then I'm going to list what that is just so we know. And so 4 pairs with itself. Okay, now I'll head to number 5. Can you stop checking for factor pairs when you find a pair that repeats? Yeah, we can. But now I need to do that explain part. When you find the factor pair that repeats, what do we notice? Well, when we find that factor pair that repeats, that means that all the factors are greater than and less than this factor pair that has already been found. Now, there is something that we notice. We have this part right up here that we didn't read our directions very carefully. It says, list the factor pairs of 16 and then find the groups. We never said our groups that he could have. So let's list our groups that he could have. Well, we can't have that 1 times 16 because remember we can't have 16 altogether. So we could have 2 groups of 8. We could have 4 groups of 4. What else could we have? We could have that 8 groups of 2. But we can't have the other ones because remember we can't have everyone in the same group and we can't have people by themselves. Now let's head on to our next part. Oh look, little fishies. A pet store needs 3 displays with the products shown. So 1, 2, 3. The boxes of kitty litter need to be stacked with the same number of boxes in each row. There needs to be at least 3 rows with 3 boxes in each row. What are all the ways the boxes of kitty litters could be stacked? Well, What quantities? Remember, quantities means what? Quantities means number. So what numbers are given in the problem, and what do those numbers mean? Well, we start out with 50 fish bowls. What other numbers do we see? We see that 48. And what are they? Boxes of kitty litter. What other factors do we see? 88 bags of dog food. Do I see any other quantities? Well, not here, but up here I see the number 3 rows and 3 boxes. So I see 3 is the number of displays and the minimum number of rows. So 3 is the number of displays, the minimum number of rows. And what else do I notice? It was the minimum number of kitty litter boxes in each row. So now that I have that, I can figure this out. So now we're going to find what are factor pairs of 48. And why 48? Well, because remember, it's asking us about the kitty litter, and it wasn't asking about any of these others. So we want the factor pairs of 48. So remember, we start at number 1. 1 times what equals 48? Well, that's 48. Then we go to 2. 2 times what equals 48? And if I don't know my 2's fact, which is perfectly okay, I think 2, 4, 6, 8, and I keep counting. Now I get to 24. Then my next one is 3. Well, if I know my rules of divisibility, I know that 48 can be divided by 3. And why is that? Well, if I did what I was supposed to, I know that when I add the digits of a number, if it equals something I can divide by 3, like 4 plus 8 equals 12, then I know I can divide it by 3. And if I still don't know my division facts well, I can add those digits again and get a single digit. And if I can divide that by 3, I know I can divide the original 48 by 3. So yeah, now I just need to figure it out. So I can count by 3. 3, 6, 9. Or I know 3 times 5 or 3 times 15 is 45. So one more group would be 16, which would be 48. Now, what about 4? Well, I know 4 times 12 equals 48. 5 is not a factor pair. 6 is a factor pair. 6 times 8, and this one I can see on my multiplication chart. 7 is not a factor pair. And then when we get to 8 times 6, we notice what? We notice that they repeat. So I'm all finished with my factor pairs. So now let's head to our last portion down here. It says, what are all the ways the boxes of kitty litter can be stacked with at least 3 rows with at least 3 boxes in each row? Well, let's look up here. I'm going to highlight the ones that we can't do. Can't do that. Why? Because it only has 1 row and it needs to have 3. Can't do that because it only has 2 rows. Here we have a good one. 3 rows, more than 3 rows, another one. And remember, we can also flip them. So we could also have 8 times 16. We could flip them and have 12 by 4. And we could flip them and have 3. Oops, I put 15 instead of 16. We could have 16 and 3. So let's write those answers out. We could have 3 and 16, so 3 rows of 16. We could have 4 rows of 12 in each row. We could have 6 rows with 8 in each row. We could have 8 rows with 6 in each row. We could have 12 rows with 4 in each. And we could have the monstrous 16 rows with 3 in each. That's it for today, guys. Good job.